Hello everyone, a pleasant morning to you all. Today we are in the NEET session of the chapter Chemical Kinetics. Chemical Kinetics. Now, before you start the working of solving of chemical kinetics, first go through all the formulas and write down a brief notes on chemical kinetics. Once the class begins, that time I will take this chapter for about 8 hours in detailed discussion of chemical kinetics for the NEET session. So, I have some set of 20 questions from chemical kinetics that we are going to solve in 2 sessions. It's very simple, very easy, and the straightforward questions comes from this chapter. Most of the questions are logic-based questions. Logical questions are there. So, some formula-based questions, some memory-based questions. All the mixtures I kept it here. So, the first question, let's see. So, before you solve the question, please write down the question or take the printout of the PDF which I have already sent you in the group. PDF na ಕೊಟ್ಟಿರುವಂತ PDF ನ ಬರ್ಕೊಳ್ಳಿ ನಿಮ್ಮ ಹ್ಯಾಂಡ್ ರೈಟಿಂಗ್ ಅಲ್ಲಿ. If not, you take down the print of that PDF for about 20 questions it has. Now let's see the first question in this chemical kinetics. So the first question, okay, see here, the first question is a straightforward question, very simple question. It has come in the AIMS NEET also. Now 3A gives you 2B. It is a reaction. Rate of reaction, that is plus dB by dt, that is the rate of change of product B with respect to time, is equal to, very simple. Let's write down this side. Now question number 1, it is given 2A, 3A gives 2B. This is a reactant, this is product. Now what is asking? Is asking plus the rate of change of product upon time is equal to what? 4 options are given. Let's find out the option later. Now this problem is based on which equation? Differential rate equation. It is based on differential rate equation. Now how to write differential rate equation? ಯಾವ ಒಂದು equation ಗೆ differential rate equation ಯಾವ ತರ ಬರೀತೀರಾ ಅದನ್ನ ಈ ರೀತಿ ಬರೆಯಬಹುದು. Now this is product, reactant, this is product. Now we know that this is coefficient of the reactant, this is coefficient of the product. How to write differential rate equation for this? I will write now. Since minus 1 by 3 by dt, why minus? Because rate of the reactant goes on, decreases and decreases. So I kept minus. So this 3 becomes 1 by 3, that is the coefficient of the reaction is equal to plus 1 by 2 d b by dt. This is the differential equation I have written for this reaction. Plus indicates rate of product always goes up, increases. Now what is asking? Is asking only so much. Then minus, you cross multiply here, this comes here, 2 by 3 dA by dt is equal to plus dB by dt. That's what it is asking. So what is the answer? Answer we got so much, that is minus 2 by 3 dA by dt, and we will search the option here. This side is turned this side. This side here is the option you can see, minus 2 by 3, that is minus 2 by 3 dA by dt. So correct option is option B. Is the correct answer. Clear? Okay, the next question, very important question, very important. See the question. For the reaction, this is nothing but decomposition of ammonia. It is decomposition of ammonia. 2 NH gives you N2 plus 3H2. Okay. If minus d by NH3 dt is equal to K1 into NH3, d of N2 by dt is equal to K2 into NH3, and d of H2 rate of hydrogen by dt is equal to K3 into NH3. First, write down the given things. Then we see the option. First, write the equation. Now, equation is something like this. Question number 2. Question number 2. And what is the question given? Question given is 2 NH3 gives you N2 plus 3H2. This is the question. Clear? And if the question is given, also something is given below, minus d of NH3 by dt is equal to, it is given K1 into NH3. Then given minus, plus d of N2 by dt is equal to K2 into NH3. Then finally given d of H2 by dt is equal to K2 into K3 into NH3. So many things are there. Now, which one is the correct option we need to find? Very simple once again. It is based on differential rate equation. So differential rate. Apply differential rate equation for this reaction. E reaction rate. Differential rate now apply MANDYA. So we'll write this minus 1 by 2 rate of NH3 by dt is equal to plus 1 by 1 only, no worries, 1 by 1 if you want to write down, no worries, or else you can eliminate it, or d of NH2 by dt is equal to plus 1 by 3 d of H2 by dt. So like this we have to write differential rate equation for the given chemical reaction. Okay, fine. Now minus dNH3 by dt is equal to K1 into NH3. We'll keep this as it is, minus, so 1 by 2 is equal to so much, this much with minus, this one with minus is equal to this one. So we can write that K1 into NH3 is equal to minus, that is dN2 by dt, dN2 by dt is equal to K2 equal to minus 1 by 3 you write down as it is. d2 by dh2 by dt, dh2 by dt k3 nh3 is common everywhere, remove it. So you can write k1 by 2 is equal to k2 is equal to k3 by 3, k3 by 3. Now divide all this value by 3, sorry, multiply by 3, then multiply by 3, then 3k1 by 2 is equal to 3k2 is equal to 3k3 by 3. And what happens? So this one, then this is 1.5. The final thing is that 1.5k1 is equal to 3k2 is equal to k3. So this is the option. Now where this option is 1.5k1 is equal to 3k2 is equal to k3, straight away you can see there option 1.5k1 is equal to 3k2 is equal to k3. So option is option C. So option C is correct. Clear? Now move on to the next slide. Move on to the next slide. Before question number 3. For the gaseous reaction, N2 plus 3H2 gives you NH3, where NH3 by dt equals 2 into 10 power minus 4 is asking what is minus dH2 by dt is equal to what. 4 options are given. We have to select the correct option. Now write down the equation. That is question number 3. Given N2 plus 3H2 gives you 2NH3. This is the given equation. Formation of ammonia, where d of NH3 by dt is equal to given 2 into 10 power minus 4. This is the given. What is minus d of H2 by dt is equal to what? 4 options. Let's find out. Very simple. Once again, same way, write differential rate equation. Take this equation, then differential rate equation. Differential rate equation will apply. So differential rate equation, once you apply, then we will break down minus 1 by 1 d of N2 by dt is equal to minus 1 by 3 d of H2 by dt is equal to plus 1 by y, because it is minus. Why it is minus? Because it is reactant, decreases in the concentration. As time passes, concentration of the product goes on, increases, so it is plus. This decreases, so it is minus. So d of N3 by dt. What is given data and what is pending data? Given data is this one, so much. Pending data is this. Then what is the use of this? Given is this, fine, because all are equal. We will eliminate it now. We can eliminate it. So First you have to write like this. Then this so much is equal to so much. Or this much equal to this much. Then write down. This I want minus d h2 by dt is equal to cross multiply. Then 3 by 2 d of n3 by then 2 by 3 d of n3 by dt is given into 2 into 10 power 4 minus 4. Then 2 to the 4 by 3 into 10 power minus 4. Or simply you can write 4 by 3 is it is nothing but wait a minute. We did the wrong steps here. It should be 2. It should be 3. It should be 6 by 2. 6 by 2 is straight answer. 3 into 10 power minus 4 is the correct option. Option A is the correct option. Option A. Is correct. Clear? Question number 4. The chemical reaction, that is O3, ozone, converting into oxygen gas. 2O3 gives 3O2. Proceeds as follows. This particular reaction takes place in 2 steps. In the first step, O3 converted into O2 plus O. One is oxygen gas, one more is nascent oxygen, which is indicating fast reaction. And the second step, O plus O3 gives 2O2, which indicating slow. Now we know that the rate law expression should be, how to write rate law expression for this? Slowest reaction is a rate determining step. In order to take place this reaction, both steps are involved, so that fastest step cannot determine the rate, where slowest step determines the rate. Now it is indicating equilibrium here, so that we will apply law of mass action to this particular fastest reaction, and we will apply rate law for the second equation. Why? Because it is slow reaction. For the fast reaction, it cannot apply rate law. Only slowest reaction is the rate determining step. So second reaction you can apply the rate law, and the first reaction will apply the equilibrium constant. That is law of mass action. So look at this. It is indicated O3 step, O3 equilibrium. For this we cannot apply rate law. So what to apply? We can apply just equilibrium constant. That is equilibrium constant. In the sense, this is equation number 1. So K1 equals molar concentration of the product by molar concentration of the reactant. Molar concentration of the product upon molar concentration of the reactant, O3. You can apply like this. For this particular reaction, we can apply rate law. Why? Because it is slowest step, which is rate determining step. Slowest step is rate determining step. So apply the rate law. So rate, that is R, is equal to, we can apply second, that is K2, the second step K2 into molar concentration of the reactant to the raising appropriate powers. This is a way of writing rate law for this particular reaction. Then is it the same? No, we cannot substitute directly, we cannot take, because both reactions are responsible for this reaction, which is indicating equilibrium. If it is given straight only single arrow mark, then we would have neglected, but now we cannot neglect it. Why? Because it is indicating equilibrium. Now just come here. K1 is equal to O2 into O, molar concentration. This bracket, square bracket indicates molar concentration. And O is equal to what? That is oxygen. Nascent oxygen is equal to K1 O3 O2. Substitute here. O over 1. Substitute here in this place. So we can get K2 into K1. Then instead of this, we can write O3 by O2. So much is over in this one. Into O3 power 1. Then we can write down new equilibrium constant. K1 into K2 is equal to K dash. We can write. So it is new equilibrium. So new equilibrium. Then we can write K dash. O3 into O3 square by O2, or sorry, should be inside. O2 or K1 O3 power 2 minus 1. So this is rate. Okay, see the step involved. O3 power 2, O2 power minus, O3 power 2, O3 power minus. So option B is the correct option. Option B is correct. Clear? Well, question number 5. It is given for a chemical reaction. Ma gives Hb. The rate law is R is equal to K into molar concentration of A whole square. If the concentration of A is double, the reaction rate will be very simple, straightforward, direct, very basic question. First of all, don't go for this type of reaction because nowhere it is mentioned. So it is just a dummy step given where you have to choose only the rate law. Rate law is this. So rate law, I will write rate law. Rate law, question 5. So rate law is equal to R is equal to K1, or just simply you write K A power square. A the power whole square. That is square bracket indicating molar concentration. See, if molar concentration of A is increased double means 2 times, is doubled means 2. Then what will be the rate? Very simple. Then rate is equal to K into 2 powers, or rate is equal to 4K. That is quadra. That means 4 times rate increases. So rate is equal to 4K. K means this constant, rate constant. K is rate constant. 4 times increases. So straightforward quadruple. So option B is correct option. 4 times increases. That is quadruple. Quadruple means 4 times increases. Okay. This is the question number 5. Direct, straightforward question. You can write down option B is the correct option. So next question. When you see the first question number 6. So what is question number 6 given? In the question number 6, it is given the conversion of A to B follows second order kinetics. If A is increased then the rate of formation of B is. Okay, then a reaction, you can write down question number 6. A reaction A to B follows second order. Then if it is second order, then apply rate law for this. So rate law, apply rate law for this. So for rate law, rate is equal to K into molar mass into Why 2? Because it is second order. Now further, what is given if molar concentration, if A is increased for 3 times. A is increased for 3 times. Then rate is equal to K into 3 power. So molar concentration of A is equal to 3 square. Then rate is equal to 90. That means rate of A is fastest for 9 times. ಎಷ್ಟು ಬೇಗ ಇದು ಕನ್ವರ್ಟ್ ಆಗುತ್ತೆ ಅಷ್ಟೇ ಬೇಗ ಬಿ ಫಾರ್ಮೇಷನ್ ಆಗುತ್ತೆ. 9 ಟೈಮ್ಸ್ ಫಾಸ್ಟೆಸ್ಟ್ ಆಗ್ತಾ ಇದೆ ಅಂತ ಹೇಳಿದ್ರೆ ರಿಯಾಕ್ಷನ್ ಸ್ಪೀಡು ವೆಲಾಸಿಟಿ ಅಷ್ಟೇ ಫಾಸ್ಟ್ ಆಗಿ ಏನು ಫಾರ್ಮೇಷನ್ ಆಗ್ತಾ ಇರುತ್ತೆ, ಪ್ರಾಡಕ್ಟ್ ಫಾರ್ಮೇಷನ್ ಆಗ್ತಾ ಇರುತ್ತೆ. ಸೊ ದಟ್ ಇಟ್ ಈಸ್ 9 ಟೈಮ್ಸ್ ಪ್ರಾಡಕ್ಟ್ ಬಿ ಈಸ್ ಫಾರ್ಮಿಂಗ್. ಸೊ ಆನ್ಸರ್ is here increase 3 times, decrease 3 times. No, it cannot decrease. Increases 9 times. Correct is option C is the correct option. Clear? Next question number 9. Question number 7. What is the question given? The question is, which factor has no influence on rate of the reaction? On which factor rate cannot depend? Straightforward. It depends on the temperature. When you increase the temperature, rate also increases. Nature of the reactant. If reactants are highly reactive, then rate is more, speed is more. Definitely it depends. Concentration also. When more concentration is taken, more will be the rate. We have seen just now. When concentration is double or triple, then rate also increases accordingly. Molecularity does not depend. So, which factor has no influence on the rate? Molecularity does not have any influence on the rate of the reaction. Straightforward, option A is the correct option. Molecularity is the correct option for the question number 7. It is option A. Question number 8. What is the question number? If the rate constant of the reaction has a value, on the value ಕೊಟ್ಟಿದ್ದಾರೆ, K equals 163 into 10 power minus 4 mole power minus half into second inverse. The order of the reaction is, ಯಾವ order ಇದು? Whether it is first order, second order, zero order or none of this. Which one is the order? Let's see. Write down the value. Now, question number 8. 163 into 10 power 4 mole inverse. That is power half. Second. So this is the value. This is the value. This is the SI. This is the value. This is the value unit. Now it's asking order of the reaction. We know that value cannot predict. Some value cannot decide the order of the reaction. Then which one will decide order of the reaction? Yes. Clue is given. Unit. SI unit always decides the order of the reaction. If you know SI unit, you can predict the order. It is straightforward, memory-based question. So sometimes NEET committee, NEET people will check your memory also. So direct memory-based question. Let's see. So option A is first order. It is first order. We know that SI unit for first order. SI unit for first order. SI unit is perfect. Option B is given second order. Order 1, order 2. For order 2 it is liters per mole per second, or simply liter mole inverse second inverse. Option C is given 0. For 0 order only just one change, that is mole per liter per second. This is liter per mole. This is mole per liter. One is per second. Or mole liter inverse second inverse. Okay. Verify this SI unit. Mole, nowhere liter is mentioned. So mole power half, nowhere half. -1, minus, nowhere half. Liter is not all mentioned. So it is not all proper unit. It is not all a proper unit. So it is none of this. Option D is correct. Clear?